everything you can hear. 100% infield. Huge thing here. This is also an island. I mean, can you even see it 3D printed? Oh no, even play around. It's very nice. So we are in the lab. 40mm cube. Whoa. Be mine. All our different materials. How do you guys like this? I think we are live. Hey, awesome people. How's everyone doing? We have many people already. Great. Santiago, Mark, you, Rob Bank, Rob the Bank. Kaden, thank you for joining. Aquatics, Dav Patch, Michael, Steven, Mark Andraka, the lucky winner. Zombie, Mark Forger. Thank you everyone for joining once again our weekly live stream. We have now three weekly live stream. So non-farm also more streams. Yeah, we're going to have 3 streams. So we're going to have the Q&A stream. I'm planning to have this Thursday will be a Q&A stream. Like we will only focus on questions. Like for example, we will go on Reddit and solve some problems. We'll go on the Discord and then solve some questions. Like the thing that we were doing before we started, all of this discussion around print busters and then all of the new ideas that we had. So we are going to have this Thursday more of praying to the internet engineers today. Yeah, I'm same here. Actually, we are not in lockdown anymore, which is very, very good news. The other news is we have to be tested every 2 days. If you miss one, then you cannot go out. So it's not I mean, you can go out, but you cannot enter anything basically because you need to have your code with the testing. So if you miss one testing, then basically you have to stay because you cannot enter anything. And to go to our office, we need to be tested every 3 days. And I was not tested yesterday, so I couldn't go to the office. But yeah, we're not in lockdown anymore. So very, very soon, hopefully next week, starting from next week, we should be doing all our live stream from our setup in the office. I may need to remove all the spider web and stuff, but after that, then it will be much more fun to do that from the office. So I was saying that the Thursday is going to be more of a Q&A and like troubleshooting kind of stream. Then the Saturday one will be the hangout one, the same as last time. So we'll go through the news and talk about stuff that people talk about in 3D printing. For example, the Bamboo Lab Kickstarter and all the reviews that came out, etc. And then we'll have the print busters most likely on my Wednesday, which will be on your Tuesday evening, I guess. But I will do a poll on Discord to see what would be the best day for this one. Or we can have the print busters on Thursday and move our Q&A earlier in the week. So we will see each other more often. How awesome is this? Okay, so first things first. Let's get some awesomeness going. And I prepared it before. For the first time, I prepared our giveaway before starting the stream. I actually had a meeting very, very early this morning, so I had time to prepare the stream very well. Hi, Loyal. Thank you for joining the stream. You should get some rest. No, when is your how do you call that, like marathon stream starting? I think it was this weekend, right? But for you, it's Thursday. So I guess in 2 days, right? Loyal is out. Yeah, in 2 days. Yeah, Loyal is going to do a 24 hours 24, 28 hours live stream. So let's see how it goes. We'll have to support that 24 hours, and you will be able to get a spool every hour, if I remember well, every hour. And I think there is much more than that. I think there's 3D gloop involved, so I don't know if it's going to be every hours or not, but you will have some 3D gloop. You will have a printer, I think, because I've seen Focus as a sponsor also of that marathon stream. So most likely you will also be able to get a printer. Going to be crazy. Yeah, I guess. Saturday is the stream. Yes. Saturday night, 24 plus stream, giveaway every hours. Yeah, that's the one. Printer or laser? Hopefully a printer. How beautiful is that? I go on Twitch, and then we have a beautiful Delta printer printing. I love Delta printer, and looks like there's another one in the background. So yeah, and then what time? I don't know. Maybe Loyal can give more information. So yeah, did we get some awesomeness going? Let me check. 12 more. We need more awesomeness. Oh yeah, because I didn't put the banner. Sorry. People are still joining, so let me put the banner. There you go. Now we should have we should start to have more entries. So today the main topic, because now I will just do one main topic, because I know we'll have a lot of topic around that, but the main topic is going to talk about our one of the print buster topics, which is flow calibration, and the main point would be, the E-step calibration and the flow calibration. Whether the idea, it all started by, if you do a E-step calibration, then you don't need to do a flow calibration, and then a lot of people are starting to discuss around that. Like, no, flow is to calibrate this, and E-step is to calibrate this, so you have to calibrate both, and blah, blah, blah. So we are going to have some nice discussion. And then I was very, very happy that Nero, well, I will call him Nero because I have no ideas of his name. So Nero 3D also bring his ideas on the topic. So I didn't know him before you presented Nero's channel to me, but definitely a very, very knowledgeable guy when it comes to all the hardware. I think he is in the Voron team, and he's building, it looks like he's building a printer every stream. I mean, I'm not joining every stream, but every time I join a stream, he is building a printer. So he may have built more printer than an actual manufacturer. But no, anyway, so he also bring his input, and I think there's a lot of interesting point. And then in the chat, there's one particular point which I think was very, very good, and go towards, yes, you have two different calibration, but a lot of good point here. And then on Twitter, we are also going to check. I posted the same stuff, like change my mind meme, and then let me check. Yeah, this one, and then also a lot of input from the community. I mean, I was like, E-step calibration and slicer flow calibration are the same. Stop doing both. Obviously, not really, stop doing both, etc. But at least we successfully triggered a lot of people, so that brings a lot of things to us. Hi, Peslis, Ted Boyer. How are you guys doing? E-steps are right on, but prints are ugly. Jerry Tech. Thank you for joining. Nero has an addiction to building printers. He needs help. Yeah, definitely. We have Loyal with a filament addiction. We have Nero with printer addiction. Then I don't know. Do we have some other print bed addiction or glue, printed glue addiction? I missed last night myself due to migraine. I'm awesome. Okay, some awesomeness going on. Great, man. A lot of great people here tonight. Yeah, definitely. A lot of awesome people. Nero is fantastic. Yeah, I totally agree. I'm actually following more and more stream in order to learn a little bit more about printer hardware and firmware, like Clipper, for example. There's so many people talk about Clipper that if I don't want to fall behind, then I have to do my homework. So I joined the Clipper Discord, and then I watch a little bit more Clipper videos, and it's actually very interesting. I asked on Clipper that whether there is any material related stuff, and on Discord, and they answered that there's not too much. But the more I look into it, and the more actually I feel like there's a lot to do compared to what Slicer can do at the moment. So a very interesting one. Hopefully one day we can do, once my knowledge is a little bit high enough so that we can start to talk about Clipper, then I would really love to talk more about this one. I really like it. I understand now why so many people are talking about it. Okay, great. So how about we do this? Oh yeah, first I wanted to give a shout out to our community members, and I'm really happy, and I'm really thankful that since we created the Discord, we had a lot of people joining, and then we had a lot of people talking about stuff, supporting each other, challenging each other ideas in order to bring our science even further. And I really love what is going on. And thank you also. A special shout out to Zombie, who is now helping an admin of our Discord and helping building a better Discord. Since he had this new role, he's actually going too fast for me. So I'm trying to keep up with. If it was only him, then you guys would already have a brand new Discord. But I'm slowing him down a little bit because I don't have time to participate to all what he's doing. But hopefully this weekend, I promise him that I will check all the new stuff. And believe me, there's a lot of awesome stuff coming for our Discord. So if you haven't joined already, you can click the link below. It's still the old link, but we have a new, nicer link, which I need to change. And yeah, so you can see some of the names here. If you have, if you just join our Discord and you need some help, you need some support, I'm pretty sure the names that you are seeing here on screen, they will be very willing to help you. I think we have a very friendly community, very open-minded community, and I'm very thankful for that. So I just wanted to have a small time to thank you, to thank everyone for that. Yeah, that's discord.polymaker.com. How beautiful is this link? Much better than the other one, right? Zombie surpassed the owner. Yeah, I told you Zombie is going way faster, and I'm very happy that he has offered his help to bring our community to the next level. Clipper requires a new main board. Yeah, well, hopefully we'll talk about Clipper soon enough. Steven, just got my Polymaker Silk copper filament today. Great. Hopefully, I've seen some picture on Twitter about someone receiving our bronze, our silk bronze. I'm not sure if it was you or not. Polyterra addict. Okay, so let's go straight into the topic. The topic today would be the E-step calibration and the flow calibration. And the idea here is that if you calibrate your E-step, I do apologize for the excess pain. If you calibrate the E-step, so E-step meaning, if you tell the printer to extrude 10 millimeter, then you need to calibrate the gear so that the gear know how many round or how many spin it needs to do in order to push 10 millimeter, right? So the idea is, if you calibrate this, then you don't have to touch the slicer flow. If you calibrate this and then on the slicer you put 110% the flow, then you are over extruding, and if you put lower, then you are under extruding. And so that was the idea. But in the community, it's not really the idea. You have to calibrate the E-step first, and then you have to calibrate the flow. And here's an example. Pretty much all the articles are the same. Pretty much all the articles start by helping you calibrating your E-step, and then we'll go through calibrating your flow, which for me, I don't understand. If you calibrate your E-step, then there's no need to calibrate your flow. And that's going to be the discussion today. And we are going to review all the arguments from people. So you can see here, our E-steps are now correct in the firmware. Okay, so there's another article that helped to calibrate the steps, and now it's the next one, which is slicer flow calibration. Aim to determine to define the correct amount of filament to be extruded by the 3D printer as directed by the slicer, right? And I wonder what aim is the step. So let me check. Where is the step? Okay, so let's check the aim. Okay, so here the aim of the slicer flow calibration is. By the way, if you guys are interested, let me put that in. So this is the article I'm using, so you guys can go around if you want. By the way, we shouldn't have any bot problem today. It's subscriber only chat, and you need to wait 2 to 3 seconds for every message every time. And if you just subscribe, you need to wait 1 minute, I think, before typing message. So all of this should remove all the issue we had last time, hopefully. So the E-step aim to define the correct amount of steps Marlin firmware needs to send to the extruder stepper motor for accurate movement. Okay, and then the aim of the flow to define the correct amount of filament to be extruded by the printer as directed by the slicer. Okay, so for me, these two are exactly the same. The aim is the same. So if you do that one, then you don't have to do that one. Okay, so that's my position. Okay, so now we are going to review a little bit people's arguments, and then we are going to discuss them. Okay, so ultra plus E-steps calibrate once and flow tweaks pertaining to filament type. E-step filament would, I guess, be at PLA since it's the most base generic type. So in this case, it's a different answer. Basically, what he's saying is you calibrate your E-step with PLA, which is the base filament. So, and then the flow, you are going to change it if you change filament. Okay, so it's not really answering. It's not really answering the question. Is more saying that E-step may be harder to calibrate for every filament. So we just calibrate for one filament, and then when we change filament, then we recalibrate the flow. We calibrate the flow. Now we don't recalibrate the E-step. So it's a little bit different topic. It's more about one is easier to do than the other one, rather than whether they have the same purpose or not, or whether you can do one without the other. We have 3DQ in the chat. That's we have started Printbuster, right? And it's when to have a great Printbuster community, we need a lot of very, very knowledgeable people. So if 3DQ can join our Printbusters community, then that would be awesome, because these guys their knowledge is really, really good. You should follow I think they also have a weekly stream. I never remember where it is, when it is, but I think it's on Thursday night. I think it's the same as us, but I think earlier or something like this. We keep flow at 100% for every rigid filament we use in our print farm, and we have gone through thousands kgs of filament. Yeah, and that's the point here. If all of your printer in the print farm has each step calibrated already for that filament, or if we estimate that all rigid filament has the same calibration, then yes, the flow should be 100%, because the slicer is going to ask, okay, extrude 1 millimeter cube, then the printer will extrude 1 millimeter cube. There's no other way. Well, there is some other argument which we are going to see. Mosquito. I like when you guys are throwing some names in the chat, and because there is the hot end mosquito, but here we arrive at the point where there is a lot of mosquitoes in Shanghai, so it's just funny. Variances in manufacturing will make some extruded gear larger or smaller than others. So even if you have several otherwise identical machines, the E-step may be different between machines. Once you know this variable is tuned the same, you can share flow tunes between them. Okay, so there's I agree, right? There you may have some differences between different printers, so you may need to calibrate all the different printers. But again, it's not really answering the main topic. Most car engine builders have to set their base timing before running. Bro, yeah, this one I don't understand. E-step control, how much filament the extruder pushes. So that's Nero, and I think he explained a little bit more in his stream, so we can go and check his stream. E-step controls how much filament the extruder pushes. Okay, so far so good. Flow, adjust the amount that come out of the nozzle. So already right here is strange, because if you push filament, then filament come out. There's nothing that disappear. Different filament behave differently once extruded. Die swell, temperature-induced expansion or contraction, density, etc. So let's review that a little bit. What he's saying is, if you push, by the way, I think that's what I wrote here, but if you push 1 millimeter cube of filament, right? So you calibrate your E-step, so your printer, if you tell him to push 10 millimeter of filament, he's going to push 10 millimeter of filament. Okay, that's calibrated. So that's a certain volume, right? 10 millimeter of filament multiplied by 1.75 pi, blah, blah, blah. So you have your volume of filament. Okay, you push that in, and then what he's saying is what's going to go out of the nozzle is different. Okay, and then he's saying because of die swell. Okay, so let's do one by one. Die swell. What is die swell? Die swell is you have your polymer, a molten polymer, right? So it's very it's viscoelastic. So you can it's like a rubber band, and then you can compress it, and then it will come back, and then you can compress, and then it will come back. Okay, so die swell means you push it through the extruder, okay, and then the extruder is going to squish it, okay, and then when it exits the extruder, then it will come back to the shape. Okay, so there is no, if you push 1 millimeter cube, then it will be squished, and when it come out of the nozzle, then it will come back to 1 millimeter cube. Okay, so there is no, die swell doesn't explain that you push 1 millimeter cube, and then because of die swell, you only get 0.5 millimeter cube, which means you have to push more in order, so in his idea, die swell will so let's say in his idea, die swell will make the volume more after the extruder. So it means his flow needs to be lower in the slicer. But for me, no, die swell has nothing to do with volume change. If you push 1 millimeter cube, you get 1 millimeter cube, whether it's being reshaped and stuff in the nozzle, or whether it's being compressed. But at the end of the day, it comes back. Okay, so that's his argument, and that's my answer to the argument is that it doesn't change. The temperature-induced expansion and contraction is the same. If you push 1 millimeter cube of material, and then at 25 degrees, so 1 millimeter cube of material at 25 degrees, whatever happened during the process, at the end of the day on your print, you are also going to have 1 millimeter cube at 25 degrees of this material. Why? Because maybe during the process, maybe it will heat up, and then it will expand, and maybe it will do some stuff, and then it will be extruded, and then it will cool down, and then it will come back to 1 millimeter cube. Okay, so for me, that's it's also not an argument that says you push 1 millimeter cube and then you have something else. And then density. So density, I agree. If you are talking about lightweight PLA, for example, so let's say you're talking about active foaming material, then I agree. Active foaming materials will foam and the density will change. If the density change, then you push a certain volume, you may have another volume because of the density change. But in all the other filament, I don't think we have this. There is a particular case which has been raised in a Nero stream, which is if your die is very long, then if you deform for long enough, then you may have this kind of stuff. But even though I think it's either negligible, either it doesn't even exist in 3D printing. And even if it does, I don't think any people has the knowledge about that, what is happening when you have that long die, and then the polymer de-entangle during that process, and maybe a density change. I'm not even sure. So, by the way, when we do a stream, I give it's easier for me to speak and give my argument, etc. And it's harder for you if you have an idea to put in the chat, but I will try to stop sometime and then check your different arguments. But at any time, you are very, very welcome to come to our Discord in the Printbuster topic. And then here we are all chatting. So you can put all the argument. And we also have some voice call on different Printbuster topic. And then you can explain better your idea on this topic. So you can listen to to the stream, and then you can take some note if you want. You can put it in the chat, and I will try to catch it. But otherwise, keep the note and then join our Discord. And then after the stream, or tomorrow or something, then we can jump again on that topic, and then you can explain your point of view. Most of the article I've seen on E-step calibration strongly recommend removing the nozzle. Yeah, I mean yeah. Okay. The Discord is an amazing place. A lot of knowledge in there. Yeah, definitely. I agree. So I've seen some long messages, most likely some. In order to chat and join the giveaway, make sure to hit. I changed the extrusion multiplier flow depending on the material and printing flow, speed, layer height, line width. The E-steps would depend on the gear reference diameter, and that won't change. I changed the extrusion multiplier depending on the material. Yeah, so you change the extrusion multiplier depending on the material, but you could also recalibrate your printer, your E-step, based on that material. So one of the other should be the same. And you also change the extrusion multiplier for printing flow, speed, layer height, line width. But that should be automatic, right? The slicer, if you put 0.2, yeah, I don't understand why you would change the flow for speed, layer height, or line width. Because if you have a higher layer height, then the slicer will know that you need to extrude a bigger volume. So it will the new 100% is that new volume. Grith, I just put this on Discord, but I think okay. So let's check. I think of it this way: E-step is calibrating the machine as a whole. Flow is calibrating the print, slicer, material differences. Calibrating E-step typically requires a firmware change. Much easier to adjust flow if you need to. Yeah. I mean, this I agree. One is easier to use than the other one. One is usually used for hardware, the other one for the software. Blah, blah. This I agree. What I'm saying is they are the same. You could calibrate one or you could calibrate the other. There's no differences. The only differences might be on the ease of use, might be on conveniency or something like this. But there's no other change. Not like Nero say, one control, what is the extruder pushes, and then it pushes a certain amount, but there is a different amount that comes out. So you have to recalibrate. You have to calibrate the extruder and then somehow calibrate something else, because this 1 millimeter cube won't be 1 millimeter cube. So that's more the point. If you try to print faster with the same flow, it under extrude. I don't know why. So this is I've thought about this also. Like, if you push your printer too much, is there a point to increase your flow? So that's another question, because if you push your printer to a point where it skips step, okay, or it grinds the filament, how increasing the flow is going to help? Because your gear is extruding, and then you're going so fast that it doesn't have time to melt, so the pressure is too great, and then your extruder cannot handle it, so it starts to grind the filament, right? If you change the flow and then you say, oh, it's under extruding, so let me push even more, like 120%, then what is going to change? It's already grinding the filament. You're just going to grind it even more, right? You can change your temperature. That's okay. You can change something else. But why the flow is going to help if you're already grinding the filament? I don't know, but it works. Yeah, I mean, I have this answer everywhere. Everywhere, the answer is the same. Yeah. You guys are questioning this, blah, blah, but it works. Yeah, I mean, if you're happy with it works, that's fine. But on Print Busters, we are about understanding what is happening, right? We're not about, you do this and then it's work, then that's it. That we just do like this. We're trying to understand, because that's through the understanding that you can make things better, right? Otherwise, Print Buster would be about you hit print, then it's working, then great, next. Or it's not working, then let's change randomly some stuff and then check again. Heat needs higher to adjust the flow compensation. Increase flow and temperature at the same time. Well, I don't think so, because if you increase flow, then you over extrude. Increasing the flow means you extrude more than what you have asked. So I don't know why we would increase the flow. So anyway, let's continue. So what I answer is, if Estep control how much filament the extruder pushes, it also control how much filament comes out of the nozzle. Otherwise, if the extruder pushes 4 millimeter cube and only 2 millimeter cube come out of the nozzle, then where did the 2 millimeter cube go? And then Estep is the mechanical measurement that should be the same for all filament. Ask for 100 millimeter of filament, it pushes 100 millimeter of filament. Flow calibration is per filament. Different filament may need more or less flow. This I also disagree. I don't think if you calibrate your Estep for PLA and then you use TPU 90, do you really think it's gonna be the same calibration? I don't think so. I haven't tried. Maybe he's right. But from a logic point of view, the interaction between the gear and the materials is so different that I would doubt that the calibration you have done for PLA will work for TPU. And if let's say you calibrate your Estep and it's the same for all the filament, then why would you calibrate the flow per filament? If ABS is extruding 100 millimeter and then PLA 100 millimeter and then TPU 100 millimeter, then why do you calibrate your flow? You calibrate your flow for what? If it already extrude 100 millimeter as you have asked. Lost in tech showed that you expand inside Bowden system. Sorry, I don't understand distraction. Increase flow and temp at the same time. Okay, 3DQ. If you're pushing your printer too hard, increase temperature. Hotter print temperature, increase the maximum volumetric flow rate. Yeah, this I agree. The CNC Kitchen test is perfect for that. It gives you a picture of what your printer is capable of, depending on volumetric speed and depending on the print temperature, what volumetric speed your printer can achieve. Once you achieve that, whether you increase your flow or not, it's not going to change anything, in my opinion, or maybe very, very negligible. I mean, maybe you can you can spin your gear so fast that maybe it add a little bit more pressure. But if you're already skipping step and if you're already grinding, spinning it faster, it's not going to solve anything. Temperature, yes. Temperature may solve something. Your extruder pushed 10 millimeter, but only 2 millimeter comes out the other end due to outward pressure on the Bowden. Builder's mark. Nick, did I miss a message from you and you want me to check, or you just want to make sure? Mark, are you awesome, Mark? Don't forget to be awesome. Gotta go to bed. You're gonna work tomorrow. Interesting argument so far. Gonna watch the rest later. Should I win the giveaway? I accept in advance. Have a good night, Irib. Distraction. So your extruder pushes 10 millimeter, but only 2 millimeter. Okay. So due to pressure to outward pressure on the Bowden. I'm not sure what you're saying, but let's say, if I understand well, what you're saying is you push, let's say you have a long Bowden tube, right? And then let's say you're printing with a very flexible filament. So you push 10 millimeter, like at the very, very beginning. Okay, you just loaded your filament. Well, actually, no. You loaded the filament, but it didn't extrude. You just load it until it arrives to the hot end. Okay, but you don't push it further. If you push it 10 millimeter, most likely nothing come out. Why? Because you basically compress the thing in the Bowden. Now you push it more, nothing come out. And then you keep pushing until something come out. Okay? So this I agree. But after that initial step, then after, if you push 10 millimeter, 10 millimeter is going to come out. It's for me, there's no question. Otherwise, where that 10 millimeter is going, if you have 10 millimeter and then you only have 2 millimeter that come out, then where is that 8 millimeter going? To pressurize the inside of the Bowden? Yes, that's I agree, but that's an initial step. That's not, once you get that at the beginning, then that's it. Maybe you need you're actually purging the material at the beginning. So you already compressed everything inside. I think that calibrating each step for every case to get exactly 100 millimeter for every 100 millimeter demanded is very important. The flow changes how much filament is being demanded by the extruder. Yeah, so I agree that you may need to calibrate your E-step for each filament in order to get what you ask for. The flow changes how much filament is being demanded by the extruder. The flow changes how much filament. Yeah, I mean, yeah. So if you ask, if the flow is 110, then you are going to ask more. If it's 90, then ask less. Yeah. So, I like how it's called on Simplify 3D. It's called the extrusion multiplier. Why I like this name is because the G code is, let's say you don't care about the extrusion multiplier. So the slicer is going to create a G code. Okay. And after it finished the G code, then it's going to take all the E and it's going to multiply by your flow, by the extrusion multiplier. That's how they call it in Simplify 3D. And I think it's more intuitive, because all the E is going to be multiplied by that. So if your E was, was 5, and then you multiply by 2, then now your E is 10. So it's an extrusion multiplier. Retraction can take up a lot of that pressure. Yeah, I agree, but it will put it back, because retraction means you remove a certain amount and then you put back that same amount. So you can retract, but after your retraction, when you extrude, then it's the same. You can lose pressure to oozing. Yeah, this I agree. But flow is not going to solve that. I had Simplify 3D extrusion multiplier. Super Slicer calls it extrusion multiplier, which I think is better, because flow, it's very vague. Flow can be a lot of things, but I'm pretty sure in all the slicer, flow is actually the extrusion multiplier. They just multiply that E to that flow, like 110% of that E or 90% of that E or something else. So basically that was the answer. And then Nero say pretty much this. So I think before, and I will already say that before, I don't think is the case, because if you mess with each step to adjust the flow rate, you run into issues. Once you start, I did a retraction, pressure advance, linear advance, blah, blah, blah. So if you mess with each step to adjust flow rate, so I agree that if you mess up the flow, I agree that all of these are related to your flow, right? But because if you mess with each step to adjust the flow rate, yeah, of course we change the each step for the flow rate, because you are calibrating how much filament is going to be extruded. Okay, you are asking 10 millimeter, and you are making sure the printer is going to push 10 millimeter. The flow rate we don't even care about the flow rate if your printer is calibrated. You get my point? If the printer do what you're asking it to do, extrude 10 millimeter, like push 10 millimeter, then it's going to push 10 millimeter. But if you change the flow, then it's going to do something else, and then it's you're over extruding or under extruding. So if you took Esteps to 200% and flow to 50%, do you think your physical retraction distance would remain the same? I guess so. Estep to 200%. So if you are asking, so 200% means let me think. So took Estep to 200%. So you are asking the printer to push 10 millimeter, and it's actually going to push 20 millimeter, right? Because it's 200%. And then your flow is 50%. So it means your slicer is going to multiply all the E by 50%. So instead of asking 10 millimeter, you are going to ask 5. So if you ask 5 and it's calibrated to 200, then you're going to get 10. Yeah, then it's the same. Griff, yes. For my answer is yes. Flow can be tuned differently if you are going for strength or surface quality. It would be easier to use the same slicer profile for different filament if you retune Estep for new filament. So let's break this down. So the first thing, I agree. You can tune the flow in order to have strength. So you can forcefully over extrude in order to put pressure on layer to layer adhesion or shell to shell adhesion. But that's something else. You decide to over extrude. Okay, so you purposely increase the flow. You purposely ask your printer to extrude more. And surface quality, I don't know. But yes, from my experience, if you under extrude a little bit, somehow you have a better quality. I don't know exactly why. Maybe because I like to see, like all my lines and stuff, which I know some people don't like. But your first part is about your decision. It's not about calibrating. Your slicer is doing things right, but you're asking him to over extrude in order to increase the bonding. It would be easier to use the same slicer profile for different filaments if you retune Estep. Yeah, I think I didn't understand the second part. I totally get it. Marcel of Axis FPV. I look at Esteps as the baseline calibration, and then extrusion multiplier as more of the fine tuning per filament. Yes, a lot of people are making the difference between one is easier to use as the other one. So in that case, why wouldn't you use the Estep baseline from factory? I mean, it's not like the factory is going to calibrate so wrongly that you have to recalibrate the Estep. I mean, for the Voron team, the Annex, the Visibot, the Ratrig, all the ones that are building their printers, yeah, of course, you are the manufacturers. You are the one that need to calibrate. Or if you are doing some strange thing to your printer, then yes, you need to calibrate. But don't ask the other people that just bought the Ender 3 to calibrate their Estep, because otherwise it's going to be wrong. Just tell them to calibrate the flow. If they calibrate their Estep, then that's it. Don't ask them to calibrate the flow then. So that's more of my point. But I totally agree that Estep is hard to calibrate. So it should be just calibrated roughly to a certain filament. And then, depending on the filament you use and blah, blah, then you can adjust the flow. You retract filament length, the Estep will affect retraction. Flow won't. Yeah, that's a good question, Santiago. Is there someone that know that? Like, if is the retraction setting affected by the extrusion multiplier? Because if it's the Estep, then yes, because that's the printer. But the slicer, is the slicer gonna affect that? So if you tell him to retract 10 millimeter, but your flow is somehow 110, is that going to retract 11 millimeter? That's a good question, Santiago. I have no idea. If someone has some slicer knowledge on that one, or we should dive into the Cura code, then we can answer that question. That's a good question. You shouldn't have to change flow setting for each model. That's infill and word thickness. Yeah. Okay, Griff. But the distance filament moves for retraction specifically, do you think they would remain the same? that would be a big difference between how Estep and flow calibration is calculated. Yeah, it seems that it's the same question as Santiago, so I don't know. I don't know whether the extrusion multiplier affects that specific E in the G code or not. That's a good. We should ask Nero. I'm pretty sure Nero knows that. Fascinating topic. Yeah, I agree. In relation to the 250% question. Okay, got it. Yeah, then I don't know. Greece, I don't know. I think Simplify 3D exclude retraction. Okay. I'm going to say that E-step are a rough adjustment and flow it's a fine adjustment. So we have to be careful when we say this, FDAV patch, because when you say a fine adjustment, it seems like the E-step is too rough. You cannot get it to extrude exactly what you need, and then you go in the flow to do that. But they both have the same accuracy, right? They both use the same stepper motor, whether you use the flow or the E-step. But I guess what you meant is you calibrate the E-step with a certain filament, a certain setup, and then you fine-tune that when you change your filament. I guess that's what you mean. I have calibrated my E-step on my modded printer to 100 millimeter and not changed them. The Prusa has never changed. Yeah. I find all of this too complicated. I just load a model and hit print. Whatever happens, happens. Yeah, I mean, that's why I want to move the print buster topic outside of the Q&A regular stuff, because some people are only looking for answers. When they come to my stream and then they ask, I have warping issue with my PTG, and in print busters, then I would go like, the stress is building up, blah 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 blah, and then your TG blah blah, and then they would leave the stream before I even give the solution. So I would separate that, and then on one stream I will just focus on solution. I have warping issue. Yeah, increase your temperature, decrease your speed. What else? Unclose your printer. Blah 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 blah, and then we won't spend too much time talking science. 3DQ, retraction distance is independent of flow, at least in Cura. Okay, there you go. So if that's the case, 1.5 millimeter retraction equal 1.5 retraction when flow is 200 and when flow is 100. Okay. So here you go, Greece and Santiago. So the retraction is not considered by the extrusion multiplier or the flow. So that means what? That means you better have your E-step calibrated, because you won't be able to affect it by the flow. Teams go. Oh yeah. Sorry. I'm getting used to. Let me. Yeah, it should be good now. Let me just make sure I'm not missing a meeting again. I usually try to free my my Friday, then we can have great discussion. Oh, I have one meeting, but at 4 p.m. So we should have a lot of time. So do you change your flow setting for different materials? I would say so, Mark and Draka. I would say so. For example, there's 3DQ that explain on the Discord, roughly explain why TPU would require a higher flow. I have to look into that more specifically. I think it does make sense. I was thinking more of gear slippage, but I think the fact that you deform the filament when you're printing. Anyway, you can check what 3DQ. I think there's a small chart on a small. Yeah, there's a quick drawing here. I have to look into it. I haven't got time to read in details. But the overall idea, I think, is there. The fact that you're deforming the filament. So I would say yes. Off-topic question: what's the best build surface for adhesion and part removal to print TPU on? I've had great success. I had great success with PC-based build plate. So BuildTech and all the BuildTech copycat. I've had great success with PEI actually also. Maybe the question is which one it doesn't work with. I think blue tape. I didn't have good success. What would be the best one? I'm a big fan of glass, glue with glass, and TPU is working well with glue and glass. So yeah, that would be my suggestion. Abdullah, glue stick and glass. Yeah, there you go. Glue stick and glass. Okay, so what slicer modify powder coated texture spring steel? Is that one single name? When I did the motherboard. Okay, so let's check the other arguments. Then there's the whole bridge flow, overhang flow, first layer flow, top infill flow, ironing flow. So, oh, actually, that's from destruction. So these you choose to affect that. You know, the slicer is going to do a great job at calculating, you know, exactly what you need, where you need it. You purposely tell him, okay, my bridge, I want my bridge to over extrude in order to bridge better. I want my first layer to over extrude because I want a better adhesion. All of this, you decide. It's not a calibration thing. You decide. It's not like, oh, my first layer is under extruding, so I need to change the flow. So if your first layer is under extrusion, then most likely the whole print is under extruding. It cannot under extrude one part of the print. That's pretty much, I think, is impossible. Thank you for all the answer. You're welcome, Brian. You can also join the Discord. You may have even more answer. And on the Discord, we have a specific channel for depending on which TPU you are using. You can go on that channel, and then you already have some people printing with it. Okay, draft 3D. As I typically tell people, each step is the amount of filament the printer thinks it's bringing in. Flow rate is the amount it wants to put out. A millimeter is a millimeter, but there are issues that can make a cubic millimeter no longer a cubic millimeter. No. For me, no. First, every time I ask this question, people make the difference between what is pushed and what is extruded. Why? It's exactly the same system. I give you an example. You know, in at school, you have this, the classes with a system, and then you put energy in the system, and then what happened to the system, etc., right? So I don't know if the same vocabulary, but in French it's called a system, and then you have the input and the output, right? So you have a system, and then you define the system as cannot stock filament. It cannot store material. This system can only have a certain volume of material, okay? So let's say you reach saturation. So that system, which is your 3D printer as a whole, has reached saturation. So if you have TPU, you pushed enough TPU, and then now it reached saturation, right? It's the beginning. It's after the purge. You have that system. Now that system, the input is a certain volume of filament. If you have defined your system as cannot have more filament after it's saturated, then the output has to have exactly the same as the input. Okay, so why do we make a difference between what's coming in and what's coming out? It's exactly the same. And I disagree with some issues can make a volume become a different volume. I mean, yes, in foaming, yes, in state change, like from liquid to solid, or solid to gas, or something like this, yes. But in the 3D printer system, I don't think there is. So I asked him, So I tell him it's interesting, right? That you can change volume. So is there any example that can transform 1 millimeter cube to another millimeter cube? I thought he would talk about foaming, which I forgot to say, except foaming, because foaming, yes, I agree. But except foaming, but he didn't answer foaming. Big example that come to my mind. Filament that is out of round, bigger or smaller. Okay? Would need more or less length to equal the same volume. But that's completely different. You are not pushing 1 millimeter. If the filament is out of spec and is smaller, then you are pushing less volume. That's why you are extruding less volume. It's not about pushing 1 millimeter cube and then you get 1 millimeter cube. More importantly, switching between nozzle to achieve the same line speed, you need much higher filament speed for 1 millimeter nozzle compared to 0.4. Also completely different. If you need more filament, then you are going to push more filament. You get what I mean? 3DQ. Extrusion demanded by the G code can be different from the amount that actually enters the hot end. This shows up when you print with a flow rate that is too high. Yes. Okay, so this is also a different question. If you ask the printer to do something and it's not doing it, okay, what can be the reason? And then you have many reasons. Your E-step is not calibrated. That's one of the reasons. The gear is grinding your filament. That's another reason. The gear is skipping. That's another reason. So all of these reasons, you know, there is actual reason why you have all of this, right? Don't forget to like this video. Thank you, Mark and Draka. EpoxyJewelry.com. Polymaker is my favorite filament these days. Thank you very much. Epoxy Jewelry. Epoxy. Let's do a small. Hey, I already had your. I think I've heard that before. Are you selling on Etsy? And then you are one of our Etsy members that can have 5% off. Is that correct? I think I know that name. Maybe not. Maybe not. Well, if you are in the US and you are selling in Etsy and you are using 3D printing materials, feel free to reach out to me. We have a 5% off discount. Just throwing a small advertisement in between our discussion. To me, the gear. Yes, all my 3D prints are on Etsy. Oh, great. Let me check. Santiago, to me, the gear teeth can deform the filament in the direction it's trying to push it, making the effective push filament less than the requested filament. Yes, I agree that depending on the filament, you may need to recalibrate your E-step or readjust your flow in order to compensate. Like when the extruder gear, yeah, partial clog, yeah. Okay. Yeah, and then the discussion didn't really end up on. I just didn't answer because after he was talking about the printer doesn't think in volumetric flow, that's purely a slicer thing. And then the slicer does all the math with the nozzle size, etc., etc. So, but I think it was not really in the topic. So it would be the equivalent of asking someone, blah blah blah. So yeah, it was off topic after that. E-step is calculated value that depend on the extruder specification and firmware configuration, number of steps with quality hardware. The slicer flow depends on the filament and hot end mostly. As the filament is a variable, it then need a calibration per spool. Yeah, but again, E-step is calculated value that depends on the extruder specification and firmware. It also depends on the filament. If the slicer flow is filament dependent, then the E-step is also filament dependent. So it looks like I didn't answer. Did I answer? Yeah, you could calibrate. You could also calibrate your E-step per spool. It's the same way, but flow is indeed easier to calibrate. So yeah, I already answered. I think this is my problem. The printer is at a company and I have it set to my slicer perfectly. Next user come along, they have different slicer that isn't configured. Then what? On that logic, I don't need to calibrate my Z, Y, X step. I just scale the model in the slicer. Yes, yes, exactly. If let's say somehow your X and Y is not calibrated for some reason and is going further than it should be, then yes, if you scale your model, which is like the flow in extrusion, then you can compensate for that. I don't know why he's asking the question. I think it's a rhetorical question. But at least the logic is there. Yes, he understands my logic. One or the other is the same. Yeah, so I had a lot of people that are, since Polymaker started, challenging some of the point, then, people think that that Polymaker don't really know what they are doing with their filament. But hopefully, not many people think that. Not setting these strings on the machine is lazy and bad design to force others to compensate for that in their slicer. So I would disagree. They can perform similar function, but are not meant to be used interchangeably. Yeah, this I agree. So he said he disagreed, but I think he agreed with me because he said, so they both have similar function, but they are not meant to be used for this and there, which I agree. I mean, the flow, they have different ease of use and stuff. So, but they have the same function. So he agreed in the fact that they have the same function, but it's better to use this one for that and this one for that. Especially now that we know that the retraction doesn't take in account. So you better have your E-step calibrated properly. I will see you all tomorrow. Yeah. See you tomorrow, Loyal. I don't think I'm going to be there for the 24 hours, but I will jump here and there to support. Stephen Poole. After I set my E-steps just right, I run a hollow cube. The cube should have 0.4 walls, but it will have a fat lines at 100% flow, like 0.44. So then I will adjust the slicer flow rate to get walls to print 0.4. And if I go back and check each step, they are still right on. Yeah, then something is going on. And we have to understand why. So in that perspective, does that mean your slicer is not very good at math? Because something is going on. Either, something is going on. So I think that was a similar question from Zombie, I think. But I think Zombie was more on the shrinkage. I don't remember. But one thing you need to make sure is, when you print, if it's the volume should be the same. But it doesn't mean if you ask your slicer 0.4 and it's 0.44, it doesn't mean the volume was different. Maybe, because it's rounded. So if you take the measurement, then maybe it will be bigger because it's rounded. It's not a perfect square, right, or a rectangle. So that's something to consider also. But definitely, if you ask your printer, if you printed 0.4, 0.2, okay, layer height, then for 1 millimeter distance, then it will calculate the volume, and then it will extrude that volume. Whether it's out of specs or something, whether it's a little bit thicker and the layer height a little bit different, then it's a different story. But the volume should be the same. Hi, David M. Slip isn't properly calibrated. It just retracted. Oh, when is the first draw? Eyes closing. Okay, I didn't understand the joke. I think we usually do one at... It's been 1 hour, guys. That's so... Oh, my God. That's so crazy. Did you guys realize that? Did you guys realize it's been 1 hour we're talking? There's no way. It's been 15 minutes. I love the live stream. I love talking 3D printing. Yeah, it's already 1 hour. How crazy is that? I love that. Okay, let's check. What time is it in 9:30? 9:30. Felt like 20 minutes, definitely. So let's do one in 20 minutes, Abdullah. You are in the Discord. You have a giveaway every single day. Okay, I also had a long discussion. Did I miss some? Yeah, I also had a long discussion with 3D Print Beginner, but it ended up by he didn't really want to spend time to explain. So, but he already have nice article, but that's the article that I wanted to challenge. But he said that I need to leave feedback in the comment or something. So, but I didn't have time. But I think it was an interesting discussion. Each step makes sure you extrude the requested amount of filament, while flow rate, calibration, fine-tune that extrusion value. Already, that message for me doesn't make sense. You calibrate your E-step in order to push a certain amount of filament, and then you calibrate your flow to change that amount of filament. Same thing as the system. Actually, all the message are using the same argument. What you push in is not what you push out, so you have to recalibrate your flow. And that argument for me doesn't work, except if you have a density change or some kind of explanation for your volume change. If you have a clear explanation for the volume change, then that's what I'm looking for. But if you don't have an explanation on why the volume would change, then I think the argument doesn't work. Because so I say the flow is more accurate than the E-step, blah, 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 because the amount of extrusion controlled by the flow rate is much finer compared to E-step. This also I disagree, because the E-step, let's say it takes 100 steps for your stepper motor to make a full spin, right? Why can the flow rate control half step? No, it cannot. Your E-step is as accurate as your flow rate. You see, the amount of extrusion controlled by the flow rate is much finer compared to E-step. No, I disagree. Because the flow rate is not using a different stepper motor. They are both using the same. If the flow rate asks a certain amount of flow, then the E-step can do the same. I mean, it's strange to say that, but you get what I mean? There is no one that is finer than the other. E-step standardize what's expected of the printer. I just got off work. I'm so tired, but I love the science here so much. Yeah, you can listen to my voice and slowly fall asleep. I'm like your science teacher at school, the one that is slowly making you asleep. E-step standardize what's expected of the printer. Let's say you have 3 printers from 3 different brands. E-step standardize what's expected of the printer. E-step is machine specific based on ideal gearing measurement. Flow accounts for variation from material to material. Okay, so now, so how do you define ideal gear measurement? Like you don't use filament basically when you calibrate your E-step. How do you calibrate? You just take the outer diameter of your gear, and then you calculate the perimeter, and then you know that if it spin a certain amount, then that's the perimeter, right? So one spin, one turn of the E-step would be the perimeter length. So that's what you think the E-step should be, right? And then when you use the filament, it will be different. And then you have to recalibrate, but you don't calibrate the E-step, you calibrate the flow. Which yes, could work. So basically, Did you get what I mean? So basically, let's say what's a typical diameter for for a gear? As you know, I'm pretty good with materials, but I'm pretty bad with hardware. But what's the typical diameter of Ender 3 gear, for example? Like what 1.5 centimeters, something like this. Let's say 1.5. So if it's 1.5 centimeters, then it's 2 pi r, right? So it's 1.5 times 3.14, right? 11 millimeter. Okay, so 11 millimeter is the diameter of your gear. Okay, so if it spin one time, then it will extrude 11 times 3.4, right? Is that correct? So if you consider the E-step and you don't use filament, you really consider that the E-step is about your stepper motor spinning, then you shouldn't calibrate. It will be calibrated in factory. I mean, I'm pretty sure in factory they don't use a filament, right? They use this method, I guess. They just calculate the parameter, which is 34.54 millimeter, and then that's how they calibrate. So it's if it spin one time, then you will extrude 34.54 millimeter of filament, and then that's it. And then when you use the filament, that number will be different. So you have to calibrate your flow. Don't touch your E-step. I like this approach. If this can be a standard, that would be great. Brian Burton, this is a silly conversation. Your argument only works if you only have one printer. If you have multiple printer, the G code that tells the printer extruder to extrude 100 millimeter of filament should extrude 100 millimeter of filament on all printer. Yeah. But what argument are you talking about? I mean, my argument is that E-step and flow, calibrate the same. Like if your E-step is calibrated, then for that filament, then you shouldn't calibrate the flow. I think what you're saying, Brian, is I don't think it's a silly conversation because we learn more out of this. What you're saying is that it's better to calibrate one in order to make your work easier with multiple printer. But that's a different story. It's like the people that says, you're not going to calibrate your E-step for each filament. Yeah, I agree. That's fine. You can calibrate the flow if you want. But I think that's a different story, Brian. But yeah, coming back to this, I think this makes sense. If the E-step is, don't care about filament, is about how many times you spin in order to extrude a certain amount of filament, but theoretical, which means you take the outer diameter, you multiply, you take the diameter of the gear, the outer diameter, then you multiply by pi, and that's it. That's calibrated. I think that makes much more sense, because otherwise, if you calibrate with a certain filament, then in any case, you'll have to change with another filament, etc., etc. So better have the E-step calibrated with no filament, which means theoretically it should be a super rigid material, right? Like that doesn't deform or anything. But you don't have to put the filament, right? You just have to do that. Every profile is set up per filament per printer. Ideally, yes. I should if the printer was properly calibrated. It should if the printer was properly calibrated. Oh, yeah. Okay. So you are answering to Brian. If you have multiple printer, the G code that tells, yeah, I mean, yes, if your E-step are all calibrated, then you can use the same G code to all the printer. Because if all the printer are calibrated, then you ask 100 millimeter filament, then it's going to extrude 100 millimeter filament, whatever the printer. They are all calibrated. The E-step might be different. like the multiplier inside the firmware, I don't know how you call it, like, then they may be different per printer, but the G code you can use the same. Sorry, I know I'm late. My caliper died, so I needed a new battery, but the standard extruder gear for one of my ender is 11 millimeter. Yeah, thank you. We had the answer from 3DQ. But yeah, so we used 1 millimeter. We use 11 millimeter, which means for each turn, it will extrude 34.54 amount of filament. So for me, that's how you should calibrate your E-step. And then that's calibrated. And then you can calibrate your flow because you are going to use a certain material and a certain setup, etc. I really like this way. I prefer this way. I mean, I don't know what is the other way, but I like this way. I will stand by the thought that E-step should be calibrated with filament to 100 millimeter. Then once set, never touch unless you change the hot end part. The flow extrusion should be the way to adjust. But it's the same because you are going to use a certain filament. Let's say you use PLA, right? But then that's the same. If you change filament, then you will have to recalibrate. Like it's just a baseline. It doesn't have any. It doesn't. Yeah, I don't know how to say, but whether you use it with PLA or TPU or no filament, it's still a baseline. You will still have to change your flow if you use different filament. I think they mean what you ask to push in isn't what gets actually pushed in, even if the stepper spins what's requested because of filament deformation, both squish and shear. Yes. Yeah. So that's why the E-step has to be calibrated per filament, the same as the flow. So whatever, they are both dependent on the same factors. The material. I'm awesome. Oh, welcome to the stream, Vices. G-code tells the extruder to move X millimeter. It doesn't have anything to say about flow or density or anything. The extruder is literally treated as another axis of the printer. Yes, I agree. So, yeah, I agree, Brian. If you tell the extruder to move X millimeter, then it's gonna move X millimeter. What's I don't understand your point. It doesn't have to say about flow. Then yeah, it has to say about flow. If you ask him X millimeter, it's to get a certain flow. Or density. Yeah, density has nothing to do. Yeah, I agree. The extruder is literally treated as another axis. Yeah, completely agree. I mean, it is the fourth stepper motor, right? I'm awesome. Schmidt Tech, thank you for joining. I have used the same 100 millimeter E-step and have adjusted in the flow. Yeah. So, Papa Bear, so you calibrate your E-step with a certain material, and if you change material, so with that material, then it's 100% flow. You don't have to change the flow because you calibrated your E-step with that material. But if you change material, you most likely will have to change your flow or recalibrate your E-step. But what you're saying is you don't want to recalibrate your E-step. It's already calibrated for one type of material. So if you change material, then you change your flow. Papa Bear, that's effective the same. E-step, machine baseline, and the flow accounts for variation. Yeah. I disagree. Filament variance can be accounted for with the flow extrusion multiplier setting. Yes. Yeah, that's what we say. I mean, it can also be the E-step calibration. I mean, it can be one or the other. Do you mean filament variance, like the diameter of the filament is different? Because if that's the case, in theory, 100 millimeter E-step, if flow extrusion is 100%, then you should get 100 millimeter. Yeah. E-step being properly calibrated instead of flow might have an effect when you change nozzle size. I currently don't change flow when I got from 0.4, 0.25, 0.8. Okay, that's good to know. I mean, flow rate might have an effect when you change nozzle size. Oh, okay. So if you calibrate your flow without calibrating, if each step is properly calibrated instead of flow, might have an effect when you change nozzle size. But what you imply in your first sentence that if one is calibrated, the other one is not. But the point of the discussion is that if one is calibrated, the other one is also calibrated. So because you say if each step being properly calibrated instead of flow might have an effect. So if in my opinion, you cannot say that in a way that if each step is being properly calibrated and flow is also, we cannot say instead of flow. Each step is calibrating the extruder. Slice of flow is to compensate the filament differences. Again, that's the same. If you calibrate the extruder with a certain filament and you use the same filament, then you don't have to change the flow. If you change the filament, you recalibrate your E-step or you compensate with the flow. When are you doing the first giveaway? Okay, we can do it now. We can do one giveaway now and one at the end. Whoa, 48. That's nice. You guys, I'm very happy when people are interested about science, because usually when you talk too much about science, then the numbers go. But great that you guys are interested. Okay, so let's do one giveaway in the middle. Let's have a small break. When changing nozzle, you should recalibrate each step. But why? Why changing nozzle means you need to recalibrate each step? Each step, the extruder doesn't know what nozzle you have. If your each step is calibrated to extrude 100 millimeter of filament, then whatever nozzle you have is going to extrude 100 millimeter of filament. So we should explain every time. If changing the nozzle means you need to recalibrate the E-step, then why? What happened to the E-step when you change the nozzle? I personally don't calibrate E-step with the nozzle hot, so I don't need how it's the same at all. I calibrate sorry, too many awesome people using the extruder off the hot end. Yeah, I mean, the way of calibrating, for me, what I like is E-step calibration. You don't use material, you don't use hot end, you don't use anything. You just use what we did. You just take the outer diameter of your gear and then that's it. The E-step is calibrated because we define the calibration as the E-step as the gear is going to spin. If you ask him, so the E-step calibration is to link the spinach or whatever you call it, how much it spin to a certain value of millimeter, right? And that is done just mathematically, which means a diameter times pi is the amount you are going to extrude with one spin, and that's it. It's calibrated. Then we don't care about each step anymore. And then you put your hot end, you put your filament, and blah, 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 blah. And then you calibrate your flow. And your flow will ensure that now the E-step is different. Now you're going to ask the extruder to extrude 100 millimeter, but it's not going to do that because of the interaction with the filament, etc. So you have to recalibrate all of this with your flow. That explanation for me is the one that makes the most sense. Sorry. Let's do the giveaway. Okay, ready? Oh, nice. We have 2 more entries. So great that we've been waiting a little bit more. Ready? 5, 3, 4, 2, 1. Oh, sorry. My mouse was on the wrong screen. Draw. And the winner of today's science topic of Print Busters is Sof L. How are you doing, Sofel? Are you still there? Yeah, I will go back to the messages. I will go back to the messages. Sofel, are you here? Sophie, Sophia, Sofiane, Sophanie, Sofel, congratulations. Are you there? Sophia, okay, you're there. Congratulations. So I think it's the first time I see your name. So let me the best is you can reach out to me on Discord, or if you don't have, let me put my email here. Okay, just send me an email, or if you have Twitter, you can DM me on Twitter, polymaker.3d, and yeah, just send me a message, and then I will send you a specific link for to choose your spoon. Congratulations again! Thank you for joining the stream. I hope you are enjoying, Sophia. Okay, back to business. Back to business. Pick up some nice silk. Yeah, if you guys have some favorite filament, you can suggest Sophia. I don't know, Sophia, if you have used Polymaker filament before, but it's gonna be in my form. At the end, there is a question that will ask you if you have used Polymaker filament before. But if not, you can ask some of our community members to recommend some filament. We actually launched 10 new SKU literally this week. So you can go and check out. There is some very, 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 very nice PTG colors. Okay, back to business. 3DQ. By the way, I will start the message after all the congratulations. So if I missed one, please just copy paste back after. All right, gotta pass out. Kids haven't been sleeping well night. Okay, see you, Griff. Thank you very much for participating actively in our discussion. Okay, 3DQ. I prefer calibrating Esteps with a rigid material instead of using theoretical diameter of the gear. This way, you can use the default 100% flow in the slicer. Yeah, I mean, if you want your flow to be 100%, then you calibrate your E-step with the material you are going to use. And if all the rigid material are similar, then most likely your flow is going to be 100% for all of them. I mean, if all of the like PLA, all the PLA basically have the same hardness, maybe ABS would be a little bit softer. But that's actually a good question. If you move from ABS to PLA, do you need to change the flow? That's a good question. Not related to expansion, because I've seen a lot of people that says if you move from PLA to ABS, you have to recalibrate your flow because ABS expand more. No, it has nothing to do with expansion, in my opinion. But the softness of the filament, the way it interacts with the gear, this has to do with calibration. PLACF is amazing. Yeah, great suggestion. When Nero builds a Voron, he calibrates E-step with no nozzle and no heat. Well, if there's no nozzle, there's no heat, right? No, just kidding. I mean, not kidding, but flow needs to calibrate per material at least. But E-step also needs to be calibrated per material. ABS is more liquidy. That's why Speed Benchy use ABS. But the fact that ABS has a higher melt index has nothing to do with calibration. Why the melt index of a material would have to do with calibration? The melt index of the material will have to do with the limitation of your printer. ABS has a higher melt index. By the way, is that true? Let's go and check. So a higher melt index material will allow you to print faster. This I agree, but it has nothing to do with calibration. If so, then you can try to explain why. Polysmooth is really cool. Yeah, also great recommendation. I mean, which material are you going to recommend that I'm going to say, oh no, it's a bad recommendation? So basically, whatever you are going to say, I'm going to say good recommendation. Polytera is amazing. Yes, great recommendation. Chrome silk is nice looking. Yes, great recommendation. Let's go and check melt index. Okay, melt index. So let's check. Okay, so you are saying ABS is better than PLA. So we have ABS here. Let's just put ABS and PLA. Okay, so in this case, PLA actually has a much higher melt index than ABS. But I'm just teasing. How do you say? I'm just messing with you because I chose a high flow PLA, which is our Polytera PLA. By the way, if you guys didn't know, our Polytera PLA is based on the high flow PLA formula. So you see this high flow? Do you see how high? You want to compare with other PLA? Check this out. Check this out. You're talking about speed benchy. You know, well, check out, high melt index material. So yes, actually you're right. If you check regular PLA like Polylite PLA, then you can see that it's almost twice the melt index. So yes, for the speed benchy, ABS is a good idea. Also because of the cooling properties of ABS. So maybe Polytera PLA is not the best because of the cooling property. But why? It has to do with calibration. For me, it has nothing to do. But yeah, it was just to show off a little bit the melt index of of our Polytera PLA. Estep and flow rate are both software solution for a hardware adjustment. Slicer flow is just a more convenient adjustment to make after the Estep is calibrated. Yes, I 100% agree. Anything in that Polymaker TL is a win for me. Yes, completely agree, Chase Piquet. I've used some chrome silk. I want a bronze similar. If you are recalibrating Estep per filament, you are doing a lot more work than you need to. Yes. I mean, again, that's a different topic. Which one is easier to use is a different topic. But definitely, calibrating the Estep every time is a lot of work. That's why instead of doing that, you use the flow because it's the same. That was my point. When we printed a 90-minute benchy on the Ender 3, I used Polytera. Ha! Did you use Polytera because you checked the melt index, or just because that was the filament around? But yeah, theoretically, Polytera should be better. I don't know about cooling, but it seems that a speed benchy, the benchy doesn't really have to look like a benchy, but you have to guess it's a benchy. So theoretically, Polytera should be good. You can try. So Nero tried a speed benchy. I tried a speed benchy with Polytera. The finish was worse than other filament. Yeah, so that's what I was talking about. Maybe ABS is better regarding the cooling, regarding the cooling properties. It would be harder to cool down PLA at a high speed compared to ABS. So that could be the reason. I'm not 100% sure. I didn't put some thought on it, but that was the idea. I see that Polymaker Polytera are profiles for the new bamboo printer. Did you get one in-house to play with? Not me personally, but yeah, bamboo and our filament works very well. Estep, set and forget. Yes, I agree. Now the question is, how do you calibrate the Estep, right? And that's fine if people have different way of calibrating them, but we have to define properly. When we start the discussion, we have to define, okay, I calibrate my Estep, this is how I do it, and then this is why I change my flow. But if we start to say I change my flow because with the heat the material expands or something dies swell or this kind, this I don't understand the logic. How does it look compared to my 20-minute benchy in I'm the Awesome channel? Oh, does it look like a benchy, 20-minute benchy? 3D printing, show off print. Does it look like a benchy? Wow, you cheat, zombie. Of course this benchy is going to be fast. But anyway, where is Vice benchy? Oh, maybe it was a long time ago. Yeah. Anyway, we go a little bit off topic because I also want to check the because Nero explained a little bit more. Nero explained a little bit more in his stream. I didn't check the melt index for Polytera. It was more for the matte surface for high uneven layers. Yeah, good point. Good point. I think that was 99% of people do. I was using basic cooling, and the hull was very melty. Yeah, I guess so with PLA. It's in awesome creator. Oh, okay. Sorry, I missed it. Okay, so let's check. I just need to find. I think it was around here.
Just lasers to measure, like, it's basically.
Actually, I remember where the benchy was when I arrived on the stream. So let me try to find.
Like, are you talking about? Do we got enough right here?
It's around there.
What is the biggest speed limitation FDM, in my opinion? The issue is you can only take plastic, take it from a solid form to a liquid form, and then back to a solid form so fast.
And this, I love that. I think that's one of the first one that answered the question from a material perspective. I mean, it has nothing to do with our current topic, but I asked him what is the biggest limitation of FDM, and he, for me, rightfully answered, or he answered what I also think, which is material limitation, like reshaping materials via melting. That's the biggest limitation, and I was happy that that he answered that. But anyway, I think I just arrived to the stream at this point.
And I will be doing a live unboxing of it, so I will be doing that.
Okay, so I'm already there.
Whenever I have to do a video call with anyone.
So on the chat, we also
well still.
I was already there. Sorry, I should have checked before, but let me
bump your speeds and feeds up. Do it. It'll handle it. I guarantee it will. It's a Core XY machine. It's well built. It's soft launch for now. It will be fully public later this month. Just kind of getting it set up.
Yeah, I was already there. Because he saw Polymaker was in the chat, and then he explained. Yeah, I was already there. Well, actually, you know what? You know what is funny? I screenshot this, right? And then that was the benchy. You know, it was almost completed. So I just went here, and then I was thinking, okay, the benchy is almost there, and then and I arrived, you know, not long ago. Then I tried to look that, but the benchy is printed so fast that actually I need to go back, like almost like, you know, all the way through there. So the benchy reference was not a good reference, because I don't have the time when I watch the stream. So
what's a vertical benchy? Oh, that's when people are putting the benchy on its back.
Oh, actually, I joined at the beginning or what?
Start print. Okay, speed up.
Yeah, I was already there. Yeah, the benchy was definitely. Oh, he didn't even started the benchy when I arrived. I thought I stayed for like 10 to 15 minutes, and then the benchy was already finished.
VHP on the flex plate.
Yeah, it's the last time I take a benchy reference on Nero stream. Definitely not a reference for time. Because in my mind, it's like a 1 hour print, so I have time. If I take the where is the benchy, then I basically know the time.
And then we'll print a stupid fast benchy for no reason. This is why I like this little tool, and it's really sticky.
Yeah, I cannot. Yeah, sorry.
Strictly mechanical thing. When you tell your extruder to put.
Oh, there you go. I found it. Okay, perfect. Sorry, chat. I started printing Polytera solely because the recycled spool and that spool each planted a tree. Yeah, do you guys know what? We almost reached 200,000 trees. Congratulations to everyone. That's a lot of trees. And six or seven different projects. all around the world. Australia, Philippines, US 2 project, Canada, Romania, Spain, and the Amazon forest, the rainforest. I think that's the 7 project. 200,000 trees in total. Can you plant some trees in my house? Okay, so let's hear.
Okay, so let's do the x-axis. Shimmy, 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 shimmy. You want to fix it as rigidly as possible. However,
okay, I think it's there. So let's
Polymaker. Okay, Polymaker. Since I am able to talk with you, and not on Twitter with 140. So the question about why you use Esteps and flow for tuning your extrusion. This came up on Twitter. There was different input from different people on which way is the proper way. You need to understand Esteps is pushing filament over a set distance. That's all it is. All math is based upon how much the filament is pushed by the extruder, and then flow adjusts it after the nozzle. So if you were to tweak your Esteps to compensate for flow, while that may work, you're going about it wrong, because these values for pressure advance, linear advance, retractions, those will also be adjusted based on improper flow. So if you're not getting enough filament outside of the nozzle, it could be multiple factors. Some filament flows better than others, different temperatures, nozzle size, back pressure, die swell. There's all kinds of variables at play there. So your Esteps is a strictly mechanical thing. When you tell your extruder to push 100 millimeters of filament, it pushes 100 millimeters of filament. At the nozzle, that's when you go into your slicer and play with your flow settings. Because once it hits the nozzle, then all other kind of variables are at play there. So your Esteps is the filament itself being pushed to the nozzle. Your flow is after the nozzle. So that's why you have to do both. And while you can get by with just like doing just Esteps and not playing with flow, leaving flow at 100, that's not the proper way of doing it, because there's more variables at play after the extruder, and that's where your flow settings and slicer come into play.
Okay, so now you get the perspective, right? I'm other 1,000 spools in that number load. I use 100%. Really? Brian, did you use 1,000 Polytera in your print farm? Well, you are responsible for 1,000 trees. That must feel good for you, no? I started printing Polytera solely because the recycled spool. Yeah, okay. Well, that's thank you for the planet. Now Nero needs to react to this video. But actually, did you understand his point? His point is you calibrate your E-step in order to properly push the right amount of filament. And then after that, you calibrate your flow in order for the right amount of filament to be extruded. Okay, so that's exactly the argument that everyone is using. And that's the argument that I disagree with. If you push 10 millimeter of filament, like he said if you calibrate your E-step, just a mechanical thing, you push 10 millimeter of filament. Why the extruder is not going to extrude 10 millimeter of filament? Where does that go? So I think he answered after, but you get. Can you link that video? Yeah, sure. I will link with the timestamp. So let's go back.
Input from different people on which way is the proper way. You need. So.
Okay, so let me share from that timestamp. Copy. Okay, there you go. If you want to go and because in the chat there is some great discussion as well. And my question about what he said is the pressure advance, etc., calculated before or after the software flow calibration. Well, my guess, yeah, that's a good point. So when you do all of this calculation, then you end up with your G code. And then after you multiply all of your E by the extrusion multiplier, or what? By the way, I guess I have no ideas, right? I mean, Nero would answer this question better than I would do. But what I would think is the slicer do all of its calculation, and after that, it adjusts the whole G code according to your extrusion multiplier. That would be my guess. But no, because the retraction is not the case. So I don't know. EM slicer flow extrusion multiplier, okay, is done first, then pressure advance. Okay. Pressure advance is done in Clipper for me. Yeah, that's another question, Zombie, which I have no ideas. Maybe we can do some research. But okay, so let's dissect a little bit. But basically, it's the same argument than the other.
The question about why you use Esteps and flow for tuning your extrusion. This came up on Twitter. There is a different input from different people on which way is the proper way. You need to understand, Esteps is pushing filament over a set distance.
Okay, E-step is pushing filament over a set distance. This is no problem.
That's all it is. All math is based upon how much the filament is pushed by the extruder.
This no problem.
And then flow adjusts it after the nozzle.
Flow adjusted after the nozzle? No. Why? If you put 110% flow, it will also it will actually play on the extrusion. It will extrude more than it should be. It's not like E-step play with the extruder gear and the flow somehow play with the hot end. You know, it's not like you extrude a certain amount here, and then there's, if you put 110, it's going to push more through the nozzle. Like there is no other motor in the hot end, right? So you cannot.
How much the filament is pushed by the extruder, and then flow adjusts it after the nozzle.
There's no after the nozzle. You get what I mean? I don't understand this. Everything is on the extruder. The extruder push or not push. That's it. That's only this. You push the filament, you don't push the filament. You push the filament, you don't push the filament. You push a certain amount, you don't push a certain amount. That's it. There is no after nozzle stuff except foaming. But I asked him after. But actually, there's no much more because he answered the same. I asked him, well, let's try to find it. But I asked him, you know, why do you need to adjust both? If you push a certain amount, there's a certain amount that come out. And then he answered pretty much the same as Twitter, like dice well, temperature expansion, this kind of thing, I think.
Why would the filaments need different flow calibration?
Whoa, how amazing is this? I just click exactly the right timestamp.
It's because different plastics behave differently. Some plastics expand once you extrude them out the nozzle. Some contract. ABS.
Some plastic expand, some contract. Well, I mean, I guess what he means is all the polymers expand and contract, and some polymers expand differently. How does that affect anything for your flow? You get what I mean? Like, why? It's like, you know, let's say I have my filament, right? And at 200 degrees, this expands 2 times the volume. Okay? Does that mean I need to extrude half the amount because it's going to expand 200%? No, because it's going to cool down after. So if you compensate the thermal expansion, then you're going to end up with a completely under extruded printed part, because whatever it expand or contract or whatever it does during the process, after the process, it's going back to regular temperature. Like your filament is at 25 degrees when it comes in, your filament is going to be at 25 degrees after. So whatever it happened in the middle, how does that affect? All right, guys, going in sleep mode now. Have fun. Yeah, thank you, Abdullah. See you in the next stream. Polymaker, how about Eastern foaming PLA for model plane? There's regular PLA. That's why it needs to be adjusted via flow. Yes, yeah, like we said before, active foaming filament is different because you have a density change. But he's talking about ABS, PLA. I mean, everyone is talking about not foaming. Nobody is putting, like, why would you do all the articles about flow and extruder if it's just about foaming? So foaming is a great argument, but it's not the argument that make people calibrate all of this. I always thought flow was the amount of pressure in the nozzle. Well, it is directly related. The the amount you extrude and the pressure, and you have to put in all the other factors, the temperature, etc. But you can get to the pressure from the flow. Melting and pushing any given filament mix. Sorry, I do understand. This is effectively the same. 100 millimeter without restriction from the hot end will pretty much be the mechanical ideal based on gear diameter, flow multiplier, then compensate for all the variation that melting and pushing any giveaway film. Okay, now I understand the second part of the message. Okay. Okay. So let's continue.
Yes, for example, it's because different plastics behave differently. Some plastics expand once you extrude them out the nozzle. Some contract. ABS, for example, contracts. So
this also I don't really understand. I think he mixed up a little bit, like that there's no, they all do the same. All the polymers do the same. They expand and they contract. It's not like PLA expand and ABS contract. But I think it's just sometime during the stream when you have a question that just come and you try to answer accurately very quickly, you maybe miss some step.
The flow rate with ABS is going to be a lower percentage than PLA.
You see? Why? This is what I mean. If you have a filament that expand, that expand with the temperature, then you need to compensate this with the flow. But that completely doesn't make sense, no? Sorry, the character limits forced me to cut the message. Yeah, sorry. I guess I cannot increase that, but yeah. Yeah, that's the problem with having a timer between two different messages. Maybe some message we go in between. But guys in the chat, what do you think about this? Why the fact that ABS has a higher coefficient of thermal expansion, you have to compensate that thermal expansion? Does that make sense for you? If when you extrude, it's at a hot temperature, so it will expand. So in order to have the same volume at 200 degrees, I mean, it doesn't even make sense. Like, why you push 25 degree Celsius material, and in order to get the same volume at 200 degrees, then you have to lower the flow. But why? It's going to go back to 25 degrees. That's just an extreme case for the foaming PLA. But all material, for dimensional accuracy, you need to calibrate at least for material. Says 1 for ABS, then 1.03 for PTG. So you mean all materials foam? That's why you have to calibrate? Because you say foaming PLA is an extreme case. So you mean all the materials, when they extrude, they kind of foam or something? Which I don't think so. I mean, except if you have a huge amount of moisture, then you create your own foaming technology. But except from that, then why? Dimensional accuracy, but that's nothing to do with foaming. You can have a foaming filament that is perfectly 1.35. Why dimensional accuracy would have to do with foaming? You need to calibrate at least for materials. Say 1 for ABS, 1.03 for PTG. I don't understand. I don't understand. PA is based on Estep. PA, you mean nylon? Nylon is based on Estep firmware. E and retraction is based on extrusion multiplier. PA, polyamide. One is G-code based. Wait. PA is based on Estep firmware. What's PA? What's PA? PA, pressure advance. Oh, okay, sorry. If you say PA to me, then it's nylon. I'm not a hardware guy. Okay, pressure advance is based on Estep. Okay, E and retraction is based on extrusion multiplier. Okay, it's a G color. Okay. So that's to answer Zombie's question, right? Here's a better question. What is the point of this conversation? Printers need Estep calibration to work. Then we use flow rate to dial in perfect print. Done. Well, I mean, if you are happy with that, then there is no point to the conversation. The point of the conversation is to understand why. If your Estep is calibrated, your printer is doing the job. Why wouldn't you have a perfect print? But again, Brian, is like I said, some people are happy with just solution, with just their experiment results, and don't need to understand what's happening. So if that's the case, then maybe the stream is not too much on this is how it is. It's more on why. If your printer is calibrated, why would you even dial your flow rate for perfect print? If your printer is calibrated, then it will have a perfect print. That's the discussion. Why do you need to calibrate the flow? Your explanation makes sense. Material properties are the same after the material returns to room temperatures. Yes, I also think so. There is specific case, right? Foaming before and after is different. Any material where the process is changing the properties of the material may have something to do with the flow. Any material that does not change properties with the printing process would not have anything. Has nothing to do with the flow. Even if it were true, the hot end volume is so small that it would be negligible, in my opinion. Yeah, I mean, when it extrudes, it may be big for like half a second, but it cooled down so quickly that this expansion doesn't really. For me, it really doesn't make sense for me. Estep is for machines and flow is for each material. At least that's how I use it. Again, Estep, if Estep is for the machine, then do we agree that we don't need material? We just calibrate it theoretically, with the parameters, the calculation we did after. And then if that's the case, then yes, I agree. Estep is purely machine. Okay, it has nothing to do with material, nothing. That's it. And then flow is when you start to put material in the system. Now you need to calibrate because material will affect all the different part of the system. In that definition, then I think for me, that's a logical definition. If someone comes to me and start to challenge, I will have answer. This is how you do that. This is how you do that. This is what is affecting by what. It makes sense. But right now, all the thing on Twitter that answered, for me, it doesn't make sense. Especially the fact that you push a certain amount and you have a different amount that comes out. Well, different material have different pressure advance setting. Yeah, I won't spend too much on pressure advance. Sorry if I don't answer or if I don't bring the topic up, because my knowledge on this is, I was about to say limited, but there is no knowledge at all. Brian, think some printers have slips and losses, so that's why you need flow adjustment. Then it's the same question for me. If your printer slips, well, I mean, yeah, maybe you have to define a little bit more. But if your meaning is that sometimes the temperature is not high enough, so your stepper motor is going to skip step or is going to grind the filament. If that's your point, then whether you increase your flow or not, it's not gonna improve it. It's still going to grind the filament. So think some printers have slips and losses, so that's why you need to flow adjustment. And again, if you're talking about material, then yes, your Estep, no material, just theoretical calibration. And then your flow is when you put a material in the system. Then that makes sense. If you calibrate your E-step for a specific material, then if you change material, then recalibrate that E-step. You don't have to change the flow. If you calibrate your printer with a certain material, then if you print with that material, then the flow is 100%. There is no particular reason why it wouldn't be 100%. Um, 3DQ, just thought about it. What about hydrolysis of PLA when it entered the nozzle? Does that change the material properties? It could be. Like I said, for the foaming stuff, if you have this the moisture issue, it's gonna kind of foam your material. And hydrolysis is about breaking down the backbone of the polymer. It will change the mechanical property. Is that going to change the physical property? I don't think so. Maybe negligible. I don't think it will change the density. So if the density doesn't change, the volume doesn't change. So the hydrolysis, I don't think so. But the fact that you have moisture may have some air gap, which may have the volume that you extrude appears bigger. The density of the material didn't change, but you have a lot of air gap inside, which as a macrostructure may change the volume, the density of the whole thing. That's how moisture can affect. But hydrolysis, I don't think so. I don't think if you lower, so hydrolysis is going to lower the molecular weight of your material because it's going to break down the polymers. If you lower the molecular weight of the material, I don't know if it changed the density, but the hydrolysis would be so insignificant, in my opinion, that I don't think it needs to be considered. I trust a calibrated extruder to push 100 millimeter, if so commanded, more than I trust filament diameter to be a perfect 1.75, or the plastic density to be the perfect spool, or spool brand to brand. Yeah, that's fine. I mean, you can calibrate you calibrate your extruder if, as all the people calibrate their E-step with the filament, they put the filament inside and then they do 100 millimeter. So if the filament is out of spec, then your E-step is out of spec. I mean, all of this calibration thing is material dependent. So as long as you have material in your E-step calibration, then it's not really, it's like a random base E-step. It's not a, that's why I much prefer the other explanation where you don't include material in the E-step calibration. You only calibrate your flow according to material, not the E-step. 2 hours now. It goes so fast. Yeah, it goes very fast. K-Sims, I calibrated my E-steps for a specific PLA and got it dead on for 100 millimeter extruded, as commanded. My extrusion multiplier in my slicer for that same filament, even the same roll, is 104.8 after one wall box. Yeah, so you are extruded more than 100 millimeter of filament. I mean, I don't even know why we are, for me, there is not argument there. If your printer is extruding 100 millimeter of filament, and it's calibrated, like you said, it's dead on 100 millimeter, and your flow is 104.8, then you are actually going to extrude 104.8 millimeter. You multiply that extrusion, right? There's no other way. You cannot. You get what I mean? Like, there's no other way. Two hours and my TPU Benchy is almost done. Yeah, I mean, Nero would have time to print a lot more than one Benchy in that time. Okay, let's continue.
Also depends on the temperature you're printing at, how fast you're printing.
Depend on the printing temperature, depend on how fast. I also don't understand why you should change your flow depending on how fast you print. or what temperature you print.
Them out the nozzle. Some contract. ABS, for example, contracts. So my flow rate with ABS is going to be a lower percentage than PLA. Also depends on the temperature you're printing at, how fast you're printing at. There's a ton of variables that will affect how much, how filament behaves, how plastic behaves once it exits the nozzle. Like when I was working in injection molding, you had to take into account plastic shrink at different rates. I've seen entire tools, multi-$100,000 tools scrapped because they were designed with one plastic in mind, but then the customer wanted to change to another plastic. And because of that, their mold for a front fascia, the plastic that used to shrink 3 thou per inch, now shrinks at 8 thou per inch. And when it's a car bumper, that's, as big as a car bumper, now nothing lines up anymore. And you have to retool the entire tool because.
So I think it's a completely different topic about the injection molding, but let's take that analogy. What he's saying is you injection mold ABS in a mold, and then that ABS is going to shrink because of thermal expansion. I also think it has more to do with the viscoelasticity of the polymer, but that's the warping topic. That's a different topic. But let's say it's about thermal expansion, thermal shrinkage. You push the ABS in, and then it's going to shrink, right? So in the case, does that mean like it's going to expand? Sorry. So you push the ABS, and the ABS expand at high temperature. Well, I don't even understand. That's the problem when something doesn't have logic. I have a hard time to. Let me listen again. Flow change via speed, because the higher back pressure caused the teeth to shear more on the filament, making the effective extruded filament less than requested. Yeah, that would make sense. Shear more on the filament. Yeah, that's a possibility. Or at least it's logical. Santiago, your argument is logical. Why we should change the flow if the pressure of the nozzle increase? Because the interaction between the filament and the gear would be different. That would be, the shear will be different. So yeah, that makes sense. If E-step is calibrated 100% perfect and you still have to adjust flow rate, does that count not only for variation in the filament, but also variation in physical layer height, Z height, and overlap? Variation in the filament, no, I don't think so, especially if you use the filament to calibrate your E-step. So let's say your filament is evenly 1.7 instead of 1.75. Then if you calibrate your E-step with that filament, then whatever the variation, it won't change your flow. It's still 100%. It won't be 100%. Sorry. And then physical layer height, Z height, overlap. Yeah, I mean it could be, because think about it. What we are saying is, if you push 1 millimeter cube, there is 1 millimeter cube that comes out. But if you do the wall check, it's only a wall check. It's not a volume check. So if your wall is 0.44, then maybe the other measurements are not correct. You get what I mean? Like you cannot calibrate your flow with just the wall stuff. Or can you? Pull up one of the CNC kitchen graph. I think that's the right direction. If you calibrate flow using a profile that under extrude, then you are compensating for that. Yeah, I mean, we all need to stay within the limitation of your printer, because as soon as you go outside of the limitation, which means, is there any graph? I think Vice, I don't know if you're still there, but I think he has let me go to I know where there is one. there is one graph. Then I can go there. And then here. So let me show you this this image. Let me download. So this is if we talk about calibration. There you go. Wow, sorry for the quality of the image. Okay. So this is this is the CNC kitchen stuff, right? That was made by Vice, and the idea here. Let me put back here. So the idea here is you basically understand the so you have how can I explain this properly without messing up? So you set a certain temperature, right? And then you try to extrude faster and faster with that particular temperature. There will be a point where the volumetric speed will be so fast that the hot end doesn't have time to heat up the material, which means it will require much more pressure to extrude. But sometimes your extruder is not powerful enough to reach that pressure, that extrusion pressure, that needed pressure to extrude, and then you will start to skip, or you will start to grind the filament. So if we check this, for example, that blue line, so you can see that it's basically extruding normally, like at 205 degrees. If you have 2 millimeter cube per second, it will extrude 2 millimeter cube per second, etc., etc., until 8 millimeter cube per second. And that's the maximum volumetric speed that your printer can do. If you start printing above that, like you increase printing speed, you increase extrusion width, you increase whatever factors that will increase your volumetric speed, then you start to run into under extrusion issue, which means your gear is going to grind the filament, which means it's going to skip step, which means something's going to happen. And if you put 10 millimeter cube per second and you realize there is under extrusion, I don't think increasing your flow is going to help, because increasing your flow will basically go down the chart even more, because you increase your millimeter cube per second. So what we're talking about is if you stay within the plateau, right? Within the printer limitation. Oh, we have Igor that just joined. What time is it there? I think it's I think it's right in the middle of the night, no? Just shortly to review a good morning, 4:45 a.m. here. Just have to go. I will watch the stream later. Yeah, thank you for dropping by, Igor. Thank you. I tagged you in my recent post. So you posted a different graph? Yeah, sorry, there maybe here. Yeah, sorry, because I have tagged everywhere. Sorry, I don't know where is that. But yeah, was it? Yeah, where were we? Brian, interesting discussion tonight. Thanks for giving us things to think about. Good night. Yeah, thank you, Brian. Thank you very much for participating to the discussion. Have a very good night. Zombie, it doesn't take much to cause under extrusion. Even slow speed can have a few percent under extrusion, especially at low temperature. Yeah, maybe. I mean, that's why this graph is very useful. Where else would the extra material go? 0.44 wall width and 0.2 layer height. My calibration cube height are accurate to within 1 layer, even when I'm printing as a slow volumetric rate. So what's the question? Where else would the extra material go? No, I think the question is where else the extra material would come from. if your E-step is calibrated properly, and then you have the layer height is perfect, all your dimensions are perfect, but your extrusion width is 0.44 and in the slicer is 0.4, then where that material come from? I think that's more the question. In general, extrusion is very linear until a specific point, then cannot extrude any faster. Yeah, I think what Santiago said about the shear stress when it requires more pressure, we'll have to. I mean, it's logical. It could affect, but I don't know how much. It could be negligible. Actually, we could just check the. You know what? That's very easy. We just do the CNC kitchen chart, and if it's usually a straight line before it goes down, then it means that it has pretty much it pretty much doesn't affect the extrusion. Polymaker, that was in reply to the discussion on my 104.8%. Oh, okay. Yeah, I mean, if your E-step is calibrated and your flow is higher, then you are going to have a higher dimension somewhere. So I'm interested in repeating the test, but increasing the motor current and tensioning the extruder further. 3D filament. Okay, there you go. Yeah, so we can see that it's slightly going down. So maybe this going down here could be compensated by the flow rate, by Santiago's explanation. That we could try that.
Yeah, recommended shaper X MZV for.
But do we? What do you guys think about our discussion? About the fact that, you know, when you push something, then, you know, the fact that the main argument from pretty much everyone, or at least everyone that answered on Twitter, was the same. What you push in is not what you get out. That's why you need to calibrate the flow. But the flow is going to affect what you push in. So, well, anyway, hopefully that was more telling. Hits the limit, cannot go further, so it extrudes within the limit. It can be compensated. Yeah. Requested flow, real flow. Yeah, I mean, I was more looking on the right, where you have less the amount of under extrusion. But yeah, that's the issue, is that you calibrate when under extruding 8%, then when print slow, now you over extrude. Yeah, definitely. That's the problem, is that the printing speed is not the same throughout the print. So the volumetric speed is not going to be the same. So that's a bad idea to compensate for high speed. Okay. So I think that was more or less. I mean, we could go to the other one, but they all say the same thing. They all say the same thing. What you push in is not what you get out. Or flow is easier to do than E-step, which I agree. Or foaming filament, which I also agree. It's not that filament pushed in doesn't equal out. Is that what is commanded to the extruder doesn't equal actual filament push through. Yeah, but then your E-step is not calibrated. So then we go back to the beginning. What I'm saying is that if your E-step is calibrated, you don't have to do anything with the flow. If your E-step is calibrated with the material you are going to print with, and your printing is within the what your printer can do, then you don't have to calibrate the flow. You don't have to take in account the coefficient of thermal expansion, the die swell, or whatever other argument we review with Nero. I think, no, it has nothing to do. That's my point. Because that's their point. Their point is, even if you calibrate your E-step, you are going to push the right amount. but it's not what is coming out. That's why you need to recalibrate your flow. Incendium. So it's not that filament push in equal push out, blah, blah, blah. For them, yes, it is the argument, because what they say is if the step is calibrated, then you have to calibrate your flow. So I will give my conclusion, which I think is the most logical. So it sounds like you should set the flow base of each printing profile, or more specifically, each print. Incendium, it's calibrated, but back pressure and filament rigidity and other things make it change based on different materials. Yeah, but then it's not calibrated. Calibrated, you calibrate for a filament, for a certain thing. Otherwise, it's not calibrated. It's like you have a certain E-step and then you calibrate your flow. You don't calibrate your E-step. That's why my conclusion is you don't use material for the E-step calibration, and then you can call it a calibration. Because calibration is you make sure that the spin of your gear turn the right amount to extrude the right amount of theoretical material. So you take the parameter of your gear, which is 35.54 for Ender 3 gear, and you say the firmware. If we want to extrude 35.54 millimeter of filament, then you spin one time. That's E-step calibrated. That's done. Don't talk about it anymore. And then you use a certain material. Then you have to calibrate that one. You can recalibrate your flow for that material if you want, but my suggestion is you use the flow to calibrate that material on that printer. That's why E-step is machine baseline and flow is a tweak on top of that. Yeah, this I agree. Which means E-step, you don't have to touch it because the factory is going to do that job. That's why I don't like all the articles. People receive an Ender 3 and then they go on Google and then they end up with this beginner guide. And then the beginner guide say, okay, first you have to calibrate your E-step. That's very important for the rest. Okay, now your E-step is calibrated with, and their way of calibrating the E-step is you use a material and then you put it in the extruder and then you do this 100 millimeter. And then, okay, your E-step is calibrated. Now let's calibrate your flow. But all of this guide doesn't make sense. Papa Bear, just as I have been saying, so do we all agree? Do we all agree that the E-step is about the machine? You don't have to use material. You don't have to. It's just all the machine. you get what I mean? Has nothing to do with the material. So and don't, except if you believe the printer manufacturer don't know how to calibrate E-step, then we shouldn't ask beginners or anyone that receive a printer to first calibrate their E-step. Everywhere, on Reddit, on Discord, on YouTube, everywhere, people talk about E-step. Going to be honest on the fence about that. Going to be honest on the fence about that. Is that an English expression? Papa Bear, E-step, don't tweak from factory. Yeah, agreed. I think we've been agreeing, just talking about different method of getting initial E-step. Yeah, I think so, Incendium. I think so. My recommendation would be not using a material so that you have a real baseline. But I mean, you could also use you have my type of people that don't use a material, that just use the theoretical thing, which I think, to be honest, factory is doing. I cannot picture factory putting a filament inside and doing a 10 millimeter. Well, actually, that's a good question. How do you think the factory is calibrating their E-step? Do they really put a filament inside, or do they do what we did? The theoretical one. Actually, that's a good question, because if the factory is using the theoretical one, then why not doing the same, when we build a printer? I calibrate each step with gear diameter too. Yeah, I think that should be the way to go. Ben, not necessarily. From the manufacturer, say you go from stock ender extruder and you go direct drive with a Titan extruder, the gearing is different. You even have a negative E-step. Yeah, I mean, if you change your extruder, yeah, of course you need to redo your E-step. The idea is that the extruder you receive is already calibrated. But if you change extruder, then yes, you have to recalibrate. I have never done E-step with gear measuring. On the fence is to be undecided. Oh, okay. Well, that's a new English expression for me. Oh, on the fence, like you are in the middle, right? And you can fall down in either way still. So you are undecided. Okay, that makes sense. Interesting English expression. With my printer, I use different number of E-step for PLA versus PSCF. Yeah, I mean, for anyone that calibrate their E-step based on material, then they don't have to touch their flow because it's already calibrated. The flow will be 100%. If you calibrate for PLA, then 100% flow for PLA print. If you calibrate for PSCF, then 100% flow for PSCF. They use a single value for all printer. They aren't truly calibrated. Okay. I mean, now the question is this. How, let's say they use a single value. That would be based on, it's only based on the gear diameter, right? So now the question is, that gear diameter, what do you think is the, maybe I should put full screen for now. What is the margin? Like if they are all of them 1 millimeter plus minus 0.1%, then they are pretty much all calibrated, right? So maybe, Ben, maybe I agree that they don't, well, this I don't know. We would have to check, but maybe they don't specifically calibrate every single printer. I don't know. But if they don't, then we have to talk about, the dimensional accuracy of their gear. Is there something to do with the stepper motor also? Is there some kind of accuracy that can be different from a stepper motor to another one? Or if the step of the stepper motor is 256, then it's going to be 256 for all the stepper motor. It cannot be like 254, 257. So if it's the case, then only the gear would be different. Calibrating E-step allows for an easier change of slicing software. Mark UFU, why? Why would calibrate E-step make your slicing software change easier? I mean, it's the same. You have to change a number, right? Whether it's calibrated or not, it's the same number. There's no, I don't know why it would be harder. Going to have to go to bed soon. Good stream. Have to watch the end of the stream. Thank you, Ted. Have a very good night. Papa Bear, I think it's basically the same as measuring the gear. If you do the 100 millimeter with a rigid filament and without the hot end restriction. Yeah, I agree. That's why I like the no material better, because it's more standardized, like they all do the same basically. Great time to wrap up this discussion and move to the other topic. For further discussion, let's move to the Discord channel. Do we have other topics today? What other topics do we have? If you want to change from one software to another. What did you say? Calibrating E-step allows for easier change. Yeah, okay. Yeah, you're right, Mark UFU. One less setting to remember to adjust. Thank you, Santiago. Okay, Zombie, show off some print. I think I'm gonna do that in the Saturday Hangout. Once we have the European team, the European community with us. Yeah, I think I think that's it. That's what I wanted to say for that topic. I don't want to make the stream too long. I think it's what time is it? I think it's 11 p.m. already in East Coast, 8 p.m. in West Coast. Single value means they calculate it based on no variance gear, no variance material. Yeah. Okay. If you printed something, any filament brand, make sure to post it on the Discord. Yes. Make sure you don't miss our Saturday Hangout. We are going through. We have a section that's going to be showing off, the community prints. So you can go on our Discord, and there is a show of print, and then you can put your print here, and then we can comment on the print. There is some pretty amazing print. It doesn't have to be our filament. If it's our filament, it's great. If it's not our filament, then just show off some nice print. Like this is not our filament, but it's a pretty amazing print. So you can just post your print here. But I hope you enjoyed. Oh, actually, you were not seeing anything, right? I was saying here. So this is not our filament, but it's a very beautiful print. So whatever print you can post it here. Okay, so I hope you guys like the this print buster topic. If you have any print buster topic, so what's a print buster topic? I want to make it clear. A print buster topic is there is a certain topic with a common knowledge. Everyone talk about this. Everyone has the same thinking about something. But if you really think about it, if you put some science, if you challenge it, it ends up being a lot different from the common knowledge. So far, we have 3 print buster topic. The first one is warping. Everyone think warping is about thermal shrinkage, and we're challenging this a little bit. We are bringing a new point of view. We are questioning that point of view, and we are bringing new science to the warping phenomenon in 3D printing. The second is calibration, E-step and flow. Everyone thinks about this stuff that you push in and it doesn't come out, and then you have to recalibrate your flow, blah, 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 or how you calibrate. So we are challenging in order to bring a better explanation about E-step and flow, and hopefully, bust a little bit or debunk this kind of thing about thermal expansion or dice well stuff, because I don't think is correct. Or you would have to explain a little bit more to me why that is correct. So that's the second one. The third one that is very new is food safety. There's a lot of, I don't know yet if it's a big print buster topic, but there is a lot of discussion about food safety. About the thing we want to bust is a lot of people think that if the filament is food safe, then your print is going to be food safe. But there's a lot to do with food safety, and the good thing is we have a lot of knowledgeable people in the industry. I think Igor is in the industry, so we can help. So if you have other print buster topic, you can go on our channel, on our Discord, live stream idea, and then you can bring your idea. And if the idea is picked on, and if we think it's a real print buster topic, it will become a real topic in our print buster topic, and then we will open a new channel, and then we'll start talking about it, and then I will talk about it on stream, and then usually you will have other YouTubers and other people starting to explain their version, and then we'll start to analyze all of this. Okay, where is that Twitch channel you keep talking about? I have a Twitch. We have a Twitch channel, Polymaker.3D. But we haven't launched our print buster yet. So this is the channel, Polymaker_3D. So if you go on the channel, I think there's basically nothing at the moment. But the print buster, all the discussion we had now will move to Twitch, and then the Q&A and the Hangout will stay on YouTube. Okay, great. Again, I was showing my screen, but I forgot to share. So this is our Twitch. So it's a Polymaker_3D, but we don't have anything yet. I need to set up the Twitch and stuff. So but I'll do that. Okay, so how about we draw new winners, and then we call it a good stream, a very good stream. What do you guys think about the stream? Do you guys think this kind of because I know some of the people leave the stream because it's too scientific, because there's multiple things I don't want to do. I don't want I want we stay open-minded, in this Print Buster. I think it's very important to stay open-minded. I don't want we get blocked on a certain idea and we don't want to listen to other ideas. We don't want to listen to other explanation. I want our community, the Print Buster community, to be very open-minded. That's very important. I think that's the only way we can bring discussion to the right direction. I've seen on Twitter a lot of time the discussion get blocked a little bit because sometime when I ask question and when I challenge, it appears to be as I'm challenging, which I am challenging, but maybe you can perceive this challenge as this guy don't want to listen to me or something. I want, but I need more explanation. That's why I'm asking question, and I don't want our community to be afraid of question. If you ask me a lot of question in the chat, I'm not afraid of it. If I don't know, I don't know. If it seems logical, it seems logical. If I really agree with you, then I agree with you, and then that's it. So I really want we stay open-minded. Okay, so that's very important for me. And on Twitter and on Discord, I don't want any non-constructive arguments, if that makes sense. Okay, was a good stream, but I did feel repetitive and at some point, but it's fun to see being talked about. Yeah, I agree. Sometimes maybe I repeated it, but I think it's because all the arguments are basically the same, and I want to make sure I go through more than one argument, and sometimes it can be the same. I agree. Good conversation, but I'm not convinced. I still think they need to be tuned separately. Yeah, that's fine. Again, that's a good point from K. Smith. The goal is not to convince. I don't want to, like we only stop the stream once you say I'm right or something like this. It's about making people think. We put the idea on the table, we dissect it together. We may end up with different understanding, which is the goal. I want people to see this dissected topic on the table, and all the people kind of, drew the idea from that, and then ask question and forge a stronger idea about what they think. That's the goal. Whether we think differently, whether we think the same, or whether we think differently, as long as your thinking has been pushed further, like more logical, more scientific, more gears that goes together, then that's the goal. Okay. Chase PK, I enjoy every second. Keep me sane while I finish my paperwork. Keep it up, guys. Thank you very much for the great feedback. Calibration is the finished product. There are different ways of getting there. Understanding why you do each part of it is what's important. Okay, let's draw a winner, and then thank you again. I mean, you guys make this possible. In Polymaker, I like this topic, but we are all kind of busy here, and having this topic in Chinese is very difficult for me. I'm more comfortable in English, so your community here and the stream allow me to just talk so much about all of these 3D printing topics. So thank you very much for joining and participating, being very active, questioning all of this, and making this possible. Okay, so let's draw our new winners in 5, 3, 4, 2, 1. New winner. Throw Firelight, thanks for the talk. Love your stream, even though I mostly lurk. Sorry, I don't understand what lurk means. Congratulations to Gianna Situ. Thank you for the feedback, Throw Firelight. Congratulations to Gianna Situ. Gianna Situ. Are you still there? After 2 hours and 40 minutes. I'm still impressed by how long our stream last. But That is amazing. So you can add her, right? So it means she's somehow listening still. Lurking is just sitting in the stream but not talking or participating. Oh, lurking. Okay, thank you. I learned so many new words at the same time. Yeah, I mean it's good. If and anytime you want to say something, you can go on our Discord, on Twitter. You can share if you have like some. If all of you has some post stream thinking, then feel free to join our Discord or any other. Jenna fell asleep almost. Great, and you were right fighting these eyes coming down. So congratulations, Jenna. You can contact me on our Discord or here. There you go. You can send me an email, and then you have won yourself Polymaker spool of your choice. Congratulations again. Okay, thank you again, everyone, for joining our live stream. And don't forget, we have now a new live stream, which is Saturday morning, Saturday morning, 12 p.m. EST, which is 9 a.m. PST, Pacific time, Saturday. And this is a hangout. There is no specific topic, but we'll just go on Discord and check the different discussion, talk about the Bamboo Labs, talk about the Anchor M5, and talk about different reviews, talk about some creators, new creators or older creators, etc. Talk about the community and talk about some maybe new products. It's more an open talk on Saturday. So thank you again, everyone, for joining the stream. It was really an awesome stream. And then I will see you, everyone, next week or on Saturday for Hangout. See you guys. Have a good one.